Hello, my friends, and welcome to the Festive Tech Calendar 2024 edition. My name is Callon Campbell, and my presentation today is called Ho Ho Hold Onto Your Hats Real-Time Data Magic from Santa's Sleigh. I'll be talking about real-time insights, where I'll be constructing a real-time medallion architecture that's tailored for telemetry data from Santa's Sleigh. This merry session will showcase how to leverage Azure Data Explorer, Azure Event Hubs, and .NET to ingest, process, and visualize high-velocity data streams as Santa dashes through the night. It's also worth noting that everything I discuss and show today can also be implemented in Microsoft Fabric, real-time intelligence, and event streams. So look for a blog post from me later in the month of December, early January, where I'll follow up and I will implement this in Microsoft Fabric. Okay, so let's get started. Nope, sorry, missed on the intro. So my name is Callon Campbell. I'm a Microsoft MVP. I work for a company called Astra. Uh, been in the industry for 25 years. I love what I do, have a lot of passion. I focus primarily on app migration, modernization, app integration, data analytics, and serverless of cloud native application development. You can follow me over my blog or on Twitter. I guess it's called X now. I love speaking at community events and meetups and participating in this type of event right here with the Festive Tech Calendar group. I think it's awesome. Great charity. I'm also one of the organizers of Canada's Technology Triangle .NET user group, which is located in Kitchener, Ontario. Okay, so let's get started. So today's agenda. Okay, how do we get the Sleigh data from Santa Sleigh? So what I'll be doing in my demo is Santa is going to be joining the F1 team and competing in some races. From that, we're going to be getting some real-time insights of how his sleigh is performing on the track, tire temperature, speed, lap times, what position he's in, total time. All kinds of insights can come from that. So I'll be using F1 as really my backbone for this demo. I'll then be talking about a medallion architecture. What is it? What's it used for? I'll be applying it to real-time insights with Azure Data Explorer and how we can process that data as it moves through the medallion architecture. And then finally, how can we visualize and get insights out of that data? So, data is flying in, no pun intended there, flying in high velocity into Azure Data Explorer, and then I'll be doing a demo. So demo today, bear with me. I will be playing Forza Motorsport, simulating the game or the telemetry coming out of an F1. I'll be driving a Santa, and then that data will be coming across real time through a dashboard that I'll have displayed. Okay, so Santa Sleigh teams up with F1. So image here, compliments of Bing AI image generator. Lots of fun pulling some of these images together. But if Santa Sleigh were to join, obviously there's going to be no reindeer. We don't want to hurt the animals. So Santa is bringing together a rad, high performance F1 vehicle that he's going to be competing with the rest of the F1 teams. So what insights can we get out of the sleigh from a race performance perspective? So Formula One, it's highly data driven, so extremely competitive, where even a tenth of a second can make a difference in terms of a race. Um, there are advanced tools, so analytics, machine learning, analyze thousands of data points per second to find out what that advantage is. With telemetry data itself, each car has over 300 sensors generating 1.1 million data points per second, and this is all transmitted to the pits in real time. From a data volume perspective, there's usually 20 cars on a circuit, so that's approximately 160 terabytes of data that's generated every race weekend. So some key uses of telemetry data. So visualize the feedback. Provides the race engineers, or elves in this case, graphical representation of what the driver or Santa is talking about in their feedback. So Santa might complain about understeering or oversteering, which might be related to tire wear observed by the elves. You can compare performance, so allow Santa to compare his performance against other elves and how they're doing. And also from a reliability check, it helps the team of elves monitor the car or sleigh, I should say, check it for running smoothly, take the most out of the appropriate decisions based on the data collected. For example, if the team notices brake discs are overheating, they can inspect the ducts in the next pit stop or check whether a piece of debris is stuck in it. Okay, so moving on. What is a medallion architecture? Medallion architecture is a data design pattern. It's a term coined by Databricks. It's a design pattern used to logically organize data. It's recommended design approach for Microsoft Fabric Lakehouses and other data warehouse systems. Um, the goal is to incrementally improve the structure and quality of data as it flows through each of the layer of this architecture. And the medallion architecture can sometimes be referred to as a multi-hop architecture. Uh, it's suitable for unstructured and raw data. It's ingested using scalable pipelines, which is outputted to the highest quality enrichment. So here's a little diagram of what this looks like. So on our left, we have our data sources. It can be anything. In this case, for my demo, we're going to be looking at the streaming perspective, but you can use anything from a data source. So streaming, databases, files. Um, then we have these three different layers. And as we go from left to right, we're improving the data quality. So we have our bronze, which typically raw data is landed. We then filter, curate it, and we end up with a silver zone. And then from Silver Zone, we aggregate business level model data, and that goes into a gold. And usually, from a reporting analyst perspective, we're coming off of gold. There are some use cases where maybe we need to look at the silver data. It's maybe more from a data engineering perspective. But data always flows from left to right. So if we ever need to change something in the gold, we always want to have the data reprocessed and go through bronze, back to silver, back to gold. Um, and that way it's very consistent. Okay, so what is real-time analytics? Real-time analytics platforms like Azure Data Explorer and Microsoft Fabric Real-Time Intelligence provides insights as soon as the data is ingested for making better business decisions quickly, handles large volumes of data with high velocity and low response times. Okay, Azure Data Explorer, what is it? So I'll do a quick intro here for those that don't know what Azure Data Explorer is, ADX for short. It's a big data analytics cloud platform, which has been optimized for interactive and ad hoc queries. So it's an append-only stream of record. So as data flows into the system, it's always appended. So we're not updating. It's not a traditional database platform where you can read, update, delete data. This one, you're always adding and always appending. So that allows us to look historically as time series of that data as it flows in, what changed between each increment, allows us to always look at the last record, allows us to do some really cool diff deltas between each record. Um, it's also high velocity, high volume, high variance, supports structured, semi-structured, free text. It's a relational query model, so you can filter, aggregate, join, do calculated columns. It's SQL-ish. It uses a database called Custo, so you're using KQL as a language for querying. If you're using Azure Log Analytics, it's basically the same thing. A lot of the underpinnings of Azure and other Microsoft technologies is using Azure Data Explorer underneath to some degree. Okay, this is a fully managed system. Supports PaaS, vanilla databases. It's been purposely built for large amounts of data coming in, talking about petabytes size, very high throughput, and for query responsiveness. And allows very rapid iterations to explore this data. So the key here is interactive and ad hoc queries. So if you have an API, you can come in very quickly, query the data. From an ad hoc perspective. So it's not like a data warehouse where it's very curated and fine-tuned. Okay, so getting data in, there's two options. There's batching and there's streaming. I'll just we're going to be focusing on streaming from the demo perspective, but I'll go over what batching is. So batching is optimized for high ingestion throughput. It's the preferred and most performant method. Data is batched according to a bunch of properties. You can set the batching policy on the database or on specific tables. So you can have a policy at the database level and everything inherits it. Um, and or you can have specific tables that each have their own ingestion batching policy. So I'll go over that in the demo when we get down to the code. So default here is either 5 minutes, 1,000 items, or a total of 1 GB. So that's a default if you do nothing and change nothing. And 4 GB is the data size limit for a batching ingestion command. So that's just if you want to ingest one little thing, you can go up to 4 gigs, but obviously you can ingest a lot more than that. You just have to do it differently. From a streaming perspective, so data is constantly being streamed. So just the difference here is batching is, if you look at that batching policy of 5 minutes, 1,000 items. So as data comes in, uh, let's say I start querying that data, it's not going to be readily available right this second because I'm just inserting it as a batch. I'm not streaming it, and it has a batching policy. So what that does is it's waiting for either the 5 minutes, the 1,000 items, or the 1 gig trigger to be set, and then that data will be compressed and then made available for consumption. From a streaming perspective, it makes the data available almost instantaneously. So it sets up a small row set as that data, and then later, as it's hitting the 5 minutes or the 1,000 items or 1 gig, default policy, the data is then compressed for future queries where it's more historical, so outside of the 5 minute window. Yeah, I think I covered everything there. So we'll be doing streaming for this demo. I'll cover over some differences when I get down to the architecture of what what we could do with a batching scenario. Okay, and then finally we have Custo. So Custo is the query language used. It's a read-only request to process data and return results. It's very fast. It's ideal for time series data. It has built-in a number of built-in functions that allow you to for your queries. Statements are sequenced by a pipe. So you can see here on the right is the example where we have storm events. There's 59,000 records. So the first thing you want to do is you always want to narrow down your time because so the output of each statement is an input into the next statement. So in this case, it's going to get everything greater than the start time of 2007, November 1st. It will then get everything in that subset, which is less than 2007, December 1st. And then it's going to look for where the state is Florida. And then so the resulting count is only 23 out of the 59,000 records. And it does this really, really fast. And so as data goes through each step, it's filtered and manipulated and then fed into the next step, like a funnel. Okay, so here's our architecture for basically this demo. How do we gain data out from Santa Sleigh into Azure Data Explorer and eventually consumed so the elves and Rudolph can analyze it and figure out how well Santa's doing so he can perform better in the next weekend's event. So on the left here, we have our data sources. So we have Santa, we have his sleigh. What I'll be doing for my simulator is I'll be running Forza Motorsport locally on my computer. I've set it up. It has the capabilities when you go into settings to stream out the data over UDP. So I have a .NET application that will be consuming that data. I'll be then streaming it or sending that data into an Azure Event Hub as a stream. It will then stream immediately into Azure Data Explorer. So inside of Azure Data Explorer here, I have three sets of tables, or I have my three zones. So we have bronze, also known as raw. So I have a table called bronze raised telemetry. So data is going to stream into that. I then have a silver or refined set of tables called raised telemetry, and lap signal. And data will flow from bronze into silver via table update policy. And then at my gold or curated layer, I have some tables which are using materialized views. This will be handling deduplication and any kind of aggregations that I might want to do. So that's my medallion side. From a consumption perspective, I'm using a dashboard inside of Azure Data Explorer, Web UI dashboard. That same dashboard you can export, just download the dashboard raw JSON data, and you can go inside Microsoft Fabric, create a real-time dashboard report, and just upload the exact same thing, change the data source, like wire it up, and that's it. The same dashboard is up and running in Microsoft Fabric. You can also use Power BI to do other types of reports if you want, or any reporting technology, Tableau, Grafana. And then at the top here, I have a little analytics API. Don't have it ready for this particular demo, but just envision I have a .NET application. It could be a function app, could be an ASP.NET web app, and from there I'll pull data from Azure Data Explorer. That's more useful than a dashboard. That can be used by the ELF engineers to get further analytics. So I'll have that in my follow-up article when I do this as a blog post. And then if we look at the top of the screen here, we have some plugins here. So Azure Data Explorer can connect to other data sources like Cosmos DB, Azure SQL, Azure Data Lake Storage as external tables. And then what I'm doing here is I'm going to do data enrichment. So as data flows in from my bronze layer into my silver, I'll enrich the data and pull in metadata related to the car, related to the tracks for the application, just so I don't just have IDs. I want to know what specific car it is, where the location of the track is, what country, the track name, all that stuff is more useful from a reporting perspective. So as data is flowing in, that enrichment is happening inline. Um, and then at the bottom here, outside scope of the demo, but I'll just talk about it, is you can set up a continuous export. And again, I'll cover that through a blog post where I'll export my data continuously from the bronze zone into an Azure Data Lake. That then allows me to reload all that information using, let's say, Azure Data Explorer or a Fabric data pipeline. And I can bring that back in. So if I want to make changes to any of my layers, update my table policies, or create new tables, and I want to reload all that data, I can just reload it from storage from a historical perspective. I think that's all I wanted to cover from this architecture. So moving on, I'll talk a little bit more detail. So again, we got data streaming in from Forza Motorsport over UDP. Telemetry is coming into a .NET application. So .NET app is receiving that telemetry and sending it off to Azure Event Hubs, which is then being streamed to Azure Data Explorer and then made available in Power BI or Fabric real-time dashboards. In this case, it's in the Azure Data Explorer dashboard. Okay, so from a configuration telemetry perspective, so if you have this game, and this also works on the EA Sports F1, actual F1 game. I don't own that one, but it also supports a data out for UDP race telemetry. And there are some other libraries out there. So if you own that game and want to try it out, but I have Game Pass, so this game's made available, so I downloaded it and tried it out. Otherwise, I usually just play it on my Xbox, which for those that have an Xbox and want to do this, run the application on your laptop, put in the IP in your Xbox, and as long as it's on the same network, it will connect. And so you can just, if you want to play on the Xbox instead, you can do that. So you want to go into settings, go to gameplay and HUD, scroll down to the bottom where it says UDP race telemetry, turn on the data out, put in the IP address, your local IP address. The default port is 5300. So change it if you want. And then from a data out packet format, there is sled and then there's car dash. So sled is like the basic information about the sled. That's what they actually call the car. And then the car dash would be inherits all of that data and adds additional metadata about like what the driver would typically see inside the dashboard. So I changed it to car dash because I specifically want that. Okay, so edge compute perspective, I have it done in applications. So shout out to Vassar Clemens. He's got up on his GitHub Forza telemetry bridge application. So I forked that. I enriched it with a little bit more metadata that I wanted to show. So when I say metadata, I mean the channel events. So I added more for my purposes. But for the most part, it's that's all. It's his application. So here's the how you run it. You can pass in a bunch of information. I'm using all the defaults. Really the only thing you need to pass in is a connection string to your event hub. So we have my event hub connection here. I have my IP. For D, I have what kind of data mode is it? So I put dash, and then for R, it's what kind of rate is it? So the default is 1, so I just explicitly called it out so people would understand. Session ID, the default is going to be year, month, day, hour, minute, second format. So it looks like a giant number. Car ID also, I'm leaving to default. So it's basically going to be the car ordinal, the car class, and the performance index. So all that information is behind the scenes. And then you can use this information to actually pull out from my metadata, from the reference information, um, what kind of car is it, what kind of class, and the performance type of it. Okay, let's see. Did I miss anything that I want to cover on that? Yeah, so it's capturing data over UDP. It supports various data encodings, so JSON, Avro, also compression, has direct integration with Azure Event Hubs. It also has configurable data forwarding rates and session handling, and allows you to do real-time telemetry, data processing, and forwarding. Okay, update policy. So I mentioned this in my architectural diagram. So an update policy is like an internal ETL. It can help you manipulate or enrich data as it gets ingested into the source table. So extract the JSON. So in this case, I'm going to be sending JSON. So I'll be extracting JSON to separate columns, creating new calculated columns, joining data in with static dimension data. That's the reference information about the car and the track. It provides an efficient way to apply rapid transformation, and it's compatible with the medallion architecture. So when raw data lands, its landing table is going to be the bronze layer. An update policy can be used to apply initial transformation and save the enriched data to a silver table. This process can then cascade where data from the silver table can be trigger another update policy to further refine the data, and then hydrate a gold layer table if necessary. And I scrolled too fast. Okay, so next demo. So we'll set up our database. So let me stop the presentation and let me go to bring over my Azure Data Explorer. Okay, so the Azure Data Explorer, you can go and I'll have to change this anyways. You can go get yourself a free cluster. So head over to dataexplorer.azure.com/free cluster. Log in with it with whatever Microsoft credential you want to do. So personal, corporate. You can set up your own cluster information. This is sitting on, and it'll ask you, approximate region in the world. So you're not picking a specific Azure data center to put it in. So you can see this one is for North America is South Central US. And then it allows you to say, okay, what do you want to do? You want to ingest data, you want to query data, you want to create a database. I've created a database called Forza Motorsport Telemetry. I can set up data connections. So in this case, I've set up a data connection, pulling in my for the event hub telemetry data. And it's going to go into my bronze race telemetry data. So let me just show you quickly what this looks like. So if I wanted to set up bring data in, then if I want to pick up another database, I could put in my cluster information here. I can switch directory to another tenant. But what I'm going to do now is I'm going to say I could put it into a new table, so I'm not going to do that. I can pick my subscription. I can pick the event hub namespace. And as you go through, this little wizard will just build what that data connector looks like. I already have it set up, so let me just go and show you what I have set up. Yes, cancel. Okay, so I have it coming in for my subscription. I'm going to this event hub namespace, this particular event hub. I create a consumer group, which is called telemetry consumer group. Target table is going to be my bronze race telemetry. I did define a mapping, so if you're coming through the wizard like here, then you want to have some of this sort of defined and set up beforehand. It will create one for you, but I find it's much easier if you go and create these tables beforehand. And then all you do in the wizard is you just wire it up, okay? And data format, I'm doing multi-JSON. It supports a bunch of different formats. So with the data coming in, if you have sample data that's inside your event hub, you kind of need to put a sample record in order to wire this up, just so it knows what the data is coming through as. So let me close that. Let me come back to my query. So here's my database on the left. You can see here, there's functions. I got materialized views. Here's my tables. So I have reference information for my cars. So I have the car ordinal, make, model, what year it is. You can see the data types that are supported. Same thing for track. If I go into my bronze car, no, sorry, we go into my bronze race telemetry. So basically, you want to keep your data very raw, right? You don't want to do any transformation on the data as it's coming in. With that said, I did add a couple extra data points. So basically, I have my raw event data, which is a dynamic type. Just think of a JSON document, but it could be anything as dynamic. So I pulled out the event data, start date and time as a date time, and then I have the timestamp as a long. I wanted to pull that out so that's not embedded inside the event data. Otherwise, I'm not doing any transformation on the event data itself. So that's happening in the silver layer. So if we go to silver race telemetry, so I've defined this table with much more columns. So all of this information is being extracted from that raw event. So I want to know the car ID, channel ID of the data. I still have my raw data as dynamic. I'm pulling out the frequency, what lap ID, the time span, all the track information. And what this does by pulling it out, it allows me to do much faster querying when I say, go and look for, go pull all data for track, circuit. You know, I don't have a good example to my head. Anyways, just go pull, Daytona for that beach, and it'll pull back all that data. So instead of me going into my dynamic data and pulling out and materializing that data into its own column to then filter, it's better if those key data points are already pulled out as a top level field. It just makes querying much faster. Okay, and then from a gold perspective, I'll just show that query. I actually don't have a gold. I'll explain that in a second. Okay, so how do we set this up? So we have my bronze layer. So I'm going to go, so this is basic Custo language for creating a table. So I'm going to create a table called bronze race telemetry. I'm going to define each of my columns. I'll define the data type. So I have dynamic for the event data. I have long for the timestamp, and for the date time, I put date time. So use appropriate data types for the data that it represents. I am then going to create my mapping. So again, when you go back into the wizard, you can say choose your own mapping, and it just allows you to do more refinement rather than the wizard sort of articulating and coming up with something. So in my bronze race telemetry mapping, I'm saying for this table, bronze telemetry, I have an ingestion JSON mapping. These are the columns, and this is where the data is going to come from. So I have a column called event data, so it matches up here. The properties of that is it's going to come from the root, so $sign for the JSON document, and the data type is going to be dynamic. So basically, the entire payload that comes through, just throw that into event data. For the timestamp, I'm going to say go to a path and do $sign dot timespan dot start TS, because that's the actual data property for the timestamp. And from the datetime, I'm going to be using the start, the timestamp dot start TS, and I'm going to do a transformation. So this is one of those functions inside of ADX. So I'm going to do datetime from Unix milliseconds, and I'm going to put that here. So just so I have a human readable version of the date. So you run each of these. I do this. I can say run, so there's my table. It already existed. So it noticed that you want to create these things so they're idempotent. So when you run it, it will just either create it if it doesn't exist. Otherwise, it will do any deltas if necessary. So that's how the script is set up. So I have my bronze race. So now I'm going to say alter my policy. So what I'm going to do is I'm going to turn on ingestion time. So remember streaming. Sorry, I want to know the time of when the ingestion happened. And I'm then going to turn on their ingestion streaming policy. So I'm going to alter table bronze, the name of my table. I'm going to say policy streaming ingestion. I'm just going to enable it. It's going to use the defaults. You can go in and change your streaming ingestion and batching ingestion policies, but right now it's the defaults. Going down to my silver layer, so here's my table that I was showing earlier. Here's all the columns and data types. If you like adding descriptions to columns, then here's an example of how you could do that. So I'm altering my table. I'm going to add some doc strings for the columns. I just picked out a couple of columns, and you can see here's my description, and you can pass in some information about the schema. I'm also going to turn on the ingestion time to true, and also the streaming ingestion. Now I'm going to go out and create a function. So this is my own function. So create or alter function. I can provide some metadata on the, give a description of what this function is. I can put it into a folder. So you can see here on the left where we have functions, materialized views. I could, for all my tables, put them in a top level folder called bronze, and then put all my bronze tables in there. So it allows you to structure your database if needed. So from here, this is the name of my function. And then the query that I'm going to use is I'm going to say, go to my bronze race telemetry. I'm looking for is not empty. I'm going to extend some information. I'm going to join in my reference information on the track. So this is how you do a join. And then I'm going to extend so all those columns that I defined, I'm going to say I'm going to extend that data out, and I'm pulling out from the dynamic type. So I'm going to say toString for the channel ID, toLong for the session ID, etc. And then for all the track information, I'm just pointing to what's coming through as the reference. I'm then going to project that all back out to what this table looks like. So I want to project it out in the exact same format. And then were to note, if I were to ever come in and create my table and add a new column after a frequency, it visually looks like it's between frequency and time span, but it's physically actually at the end. And that will give you an error whenever you do a projection. The order of your projection needs to match the order of your table. properties. You can go in and do an alter table and specifically put it in the middle. But if you just did the create, it just puts it at the end, not in the middle. Okay, moving along. So we have my function now. So this is gonna, so I had this function, which will say, hey, go to this data and parse it out, join in my reference information, and then project it out. And it's gonna go into, well, we don't know where it's gonna go to right now. We just know if I run this, it's gonna project it out. So what I wanna do now is I'm going to disable my streaming ingestion. I have this right now because I've turned things on. So just showing you a real world scenario. So if it's already on, you can't go alter your streaming ingestion policy. So you need to disable it and then you want to turn it back on. If you're just setting things up in the beginning, then obviously you could go put this policy update in because you're going to be creating it. So I'm going to alter my table, silver race telemetry. I'm going to apply a policy update on it. So the source of my information is going to be the bronze table. The query to run, so I'm putting a function here right now, but it could be just, I could inline write a very simple Kusto query. I like using pointing functions. That way it's outside and it's better to manage. Otherwise it's inside this string and sometimes it's hard to see if you have errors and whatnot. I'm going to turn it on, so I'm going to enable it, make it transactional so that everything has to pass, and I'm just showing the defaults here. So that's how that would run. Then I would enable my streaming ingestion again, and now as we go, so this is other tables. I'm not going to go into them. Following the exact same process. So I'm going to define a table for my lap signal. I'm going to create a function for parsing out the lap signal information. Do another table update policy for the lap signal. And again, it's pointing to the lap signal function. I'll turn it back on. From a gold layer perspective now, so I'm going to create two tables. Create two materialized views, which look like tables. I'm turning on backfill for true. So as soon as I run, or as soon as I run this, it's automatically backfilled. I'm going to say auto update schema is true. And again, I could put in the doc information and what folder I want to put it. But the name of my materialized view is called gold race telemetry deduped. I'm putting deduped in the name just so from a consumer's perspective, they know what it is. So data is all deduped here. Whereas a silver table is not deduped, it's more time series. So every single time an event comes in, I can see all of them. So if I want to see all of the signal events over the course of the race, I'm going to be using silver. Otherwise, if I just want to see the last and latest result, I'll do the gold deduped. So this query here for the materialized views, I'm going to be querying the silver race telemetry. And then I'll be summarizing, and I'll be doing an arg max. So I'm not doing any aggregation here, I'm just pulling back the latest record. And then, so you want to put in the column names that will make that unique. And I did the same thing for lap signal. So that is my database code. So again, I'll have a I'll show you, I'll have it up on my GitHub where you can pull all this information if you want to recreate it yourself. Feel free. So all this information, the presentation, and everything else I'll put up on GitHub. Okay. And Teams is bothering me. Okay, let's go back to presentation. So we set up our database. Now I'm going to show a data flow. So from a data flow perspective, we have my data flowing in as JSON. So it's going to go through that bronze table. It's going to use the ingestion mapping. So it's going to land here in my bronze telemetry when it's ingested. So as data is coming in, the table update policy is going to say, hey, data is coming in on that table because it's listening for it. So as data is flowing in, it's immediately going to run this function that says, go do this. And it's being scoped to the data that's being ingested. So when it runs this function, it's not running it on the entire database, it's running onto the scope of the data being ingested. So it's going to copy and transform that data. It's going to land it inside the silver table. is where basically all of this that I showed is going to get stored. And then I have a materialized view that says, hey, listen to the gold silver table. And this is not as fast as, instantaneously, but it is, within seconds or, low minutes, is kept up to date. So as data is flowing into my silver table, it's the gold table will be always kept up to date. So if I ever query my gold lap signal deduped, where this session, I'm always going to have the latest record, with a very slight latency, but it's still pretty real time. So that is the flow of my data. So data is flowing in, and I want to see if I want to say query my gold lap signal, and just show me all the latest information for my car right now. So I'm looking for everything for that particular session. Then that's where I would do. If I want to see historically, then I'm going to be querying off my silver table, and that's what you'll see when I get into the dashboard, what that looks like. Okay, so now we have my real time with the dashboard. So go back to Query Editor. So here is my dashboard. So if you go into dashboards, I'll start from the beginning. I have two dashboards, so we'll be focusing on the first one. You can share this out to people if you want, just give them access, make it public. But here's my dashboard right now. I have a few filters, so I'm looking for specific sessions. So this is a session from yesterday. I did a race at Lime Rock Park. Length of their track is 2.41 kilometers in Connecticut, USA. Total number of signals that streamed in was just over 15,000, almost 16,000. There is latency of data showing up here, so I'll explain that. So latency you see here is because it's coming in so fast. I'm going to Event Hub. Event Hub does have the minimum is 20 seconds latency that it has. So as I'm playing this game, you'll see the latency fluctuate, and as you get later and the more it's streaming in, this does change. I am using free Azure Data Explorer, so that incurs some higher latency. And I'm also not paying that much for my Event Hub, so that also incurs some latency. So it depends. These numbers can come down, or the latency number can come down, but I did want to be honest and show it up front of just what it looks like. Okay, then moving on. So we have our driver information. So this is currently what's happening. So again, this is the end of the race. So you can see this is my car ID. So this is the car. This is the performance index, and this is the type of car, like the class of car. Um, I do want to change this and have the car, like all this information about the car, be separated. And I think I would prefer if this was just the actual driver, so I could put my name. Everything is just me right now, but if I wanted to share this out and have multiple drivers all do laps and whatnot, then I want to know, I want to be able to compare drivers. So right now, it's all my data, but that would be an improvement that I would want to do. So you can see here at the end of the race, I came in position 3. I did 3 laps. My current lap, or the last lap, was 1 minute 2 seconds. My total race time, 3 minutes 19 seconds. And these are very close to what the actual game will show you. And I have a screenshot. I'll show you what the game dashboard shows you at the end. They're off by like 1 or 2 seconds from what the game sends out. I could refine the data that's being sent out to improve it a little bit, but you get the idea for this. Also can pull out what my best lap is and what my last lap was. And the time gained, lap over lap, or from the current lap from the last lap, what the time gain was. I go to my lap performance. If you want to drill in here, you can see the data. So here's my laps. You can see what the difference is. So this is I'm using a diff difference. So this is something really easy to do in ADX, but really hard to do in other languages like SQL. So I could just say, show me in this column what the difference was between the previous record and the current record. And that's what that's doing. So you can see what that difference is between the laps. Close that down. continuing on the left-hand side here, we have tire temperature. If I blow that up higher, you can see all the tires. I have, the front left, front right. So this is time series. So this is the silver table. So most of the queries on this dashboard are currently going off of the silver because I do want the historical aspect of it. Some of them go off the gold, like the track information, the latest, like because that's I don't care about historical. I just want the current value of it. So you can see here tire temperature started 175, 158, I should say, and you can see as it's going through, all the information about this. That's my tires. So there's a lot more information that, again, 71 signals are being sent out, so I'm not using all 71. There's tire pressure, tire temperature. You can find out the height as the car's going of the suspension as it goes up and down. So pretty much in game, when you go and you enable the metrics or the metadata just showing you diagnostics, all of that diagnostic information is captured and you can do something with it. Going on the right hand side here, we have our steering. So you can just see whether I steering left, steering right, what kind of degree it was, a slight steering over time. We have my gear and clutch information. So what gear I'm going in. So it goes up to come on, fifth gear. So each car is different in terms of what gears you can go through. And then this is the position of the car over the duration of the race. You can see here, I started at race position 13, went down to 12, so slowly over the race, I was making my way down to top position, but I finished the race in third position. So that is everything about this race. Again, if you click on these dashboards, I can go into the data. I can do more. I can change my visualization if I wanted. I could add more filtering per se. I can go and where is the SQL? It's on the other page. Oh, let me come back here. This is some nice information that this does ADX is automatically doing for you. So it can see for these columns that I'm displayed, it knows the min, knows the mac, knows the unique value for all of them. It's pulling back all this information. So this is all calculated and presented for you. It's not the query I actually wrote. So if you want to see the query, you can go view query. So each of the widgets here has its own query and you can go down and look at it. So I am passing in where it says let session ID, that's not hard coded. That's actually pulling in one of the parameters. So the more parameters I use, those would come in and they would just show up here. Just so if you copy and pasted it, you could run it as is. So these are all my queries. And again, this will be included as my artifacts in a blog post. If I want to download this, I can say download dashboard to a file. So it goes down to a JSON file. And then if I were to go into Microsoft Fabric, create a real-time dashboard, and let's say I want to do this over there, but still point to ADX, then I can just say import file. I forget what the terminology is. It's slightly different, but it looks the same. I just import file, change the name of my data source. From a settings perspective, if I go into editing, I can turn on continuous refresh. So I'll do that when I run my game. So auto refresh I can turn on. I can put what the default refresh rate is, currently set to 10 seconds. And so let me go ahead and update that for when I do my demo in a second. I'll save that. Okay, and then historically, you can see all my other races that I've done. So I can just change another one. Data loads instantly. So 36,000 data points happened here. This game I did finish in first, yay. So all of my sessions, going back to October here in terms of metadata. Some of the early sessions, the dashboard's broken because I just didn't have the data to support it. So I did changes to Vaster Clemens .NET application. I wanted to capture more information than what was currently being captured. So some of my earlier races don't work. And I want to enhance this going forward. I want to add in some new pills or if we go back to editing here, I can add in new parameters. So right now I have my time range, my session ID. So I want to put in some new ones. If I wanted to add a new one, I could give it a label. What type of parameter type is it? Give it a name, variable name, what kind of data type. Show it on the page. So which page? So that's this part right here where it says pages. Um, you can also have it this parameter be query based. So if you did query based, maybe you're querying some reference data. In which case you could cache that, so it's not constantly querying your reference information. That would be so. Use that strategically. Don't just cache everything. But this is how you add a parameter to show up. So in the future, and again, I'll blog post how to do this specifically, would be I want to put in filter by circuit. So I want to be able to do the circuit type, the name of the circuit, because there are different names. Sometimes there's sub-circuits. Maybe look for tracks that are within a specific range of kilometers, and what location, what country. So there's all kinds of tracks over the world. And actually, I should show you the tracks. So if we go to my reference information and just come down here, so I'll just say reference tracks without where clause. So here's all my tracks you can see. So this information, I'll include where to get it from. There's another GitHub repository where someone was kind enough to share it out. So you get the track ordinal information. So this is what the game is sending you, which doesn't make sense. So it was nice that we were able to augment it and show this. So I can see what country it's coming from, the length, what track it is, what country, like in the country, what location is it. So it's either showing the city or state. And then the other one I had was reference cars. So here's all the cars that when you play, you want to get information about those cars. So there are a lot of cars, 614 of them. And so when I do a gaze, I'm just randomly running a track. So it's going to be a random track, random car, but you can see here it's picking out what it is, what make and type. So that information I do want to surface up into my dashboard, just like the track information. So that'll be a future enhancement that I do. So this information reference and track for tracks and cars, that data is being joined as the data streams in. So every time a telemetry point comes in, it joins this table, enriches the output going to the silver table, rather than it better practice to do that in this type of database than doing it like you would in SQL Server, where you say I'll join the data at the time of the query when I'm reporting, just because this is better to do it this way. I'll go in more depth. I need some more water, so I can't really go into depth of that right this second, but I'll cover that in more depth in the blog post. So my apologies for not saying that right now. Okay, so there is, let me go back to dashboard, set it up for the next demo. This was auto refresh is turned on and continuous. Okay, so there's no new sessions right now, so I'll need to come back in and change the session to the new session as it gets created. So let me minimize this. Okay, I'm going to put this kind of up here, make it smaller, just so you can see data is coming in. Okay, next demo is, okay, race time. Okay, let me bring up Those are Motorsport. Okay, so here is my Vassar Clemens repository. So again, I forked it. Forza Telemetry Bridge is the name. I've gone into Forza Bridge itself. All set up to run. So bin
update. Okay, so there is my connection. Yeah, you're seeing my access key. That will change after the video, but I'm going to set it up to run. So starting record at 1 hertz. Evil tenant, here's my session ID. So currently it's the same. And we'll be sending the telemetry data to my agenda. And the data will flow through as JSON. So no more telemetry is coming in. Go up to my dashboard. So there's a new entry. And you can see data is already flowing back in.
Let's go.
Okay, so let's
Wait for the latency to catch up here. So see no more events taking over. So kill that. Here's my track. You can see metadata coming through, on, circuit, location, 2 kilometers, 2 miles average, that, branch, uh, race time, 7:54, 7:56. So again, a little too lean on my queries. I could probably get that accurate. Best lap 3:51, best lap 3:52. About a second difference there. Lap performance. Zoom in on right click it, give it some pressure. Yeah, so that's my race. I mentioned the pages earlier. This is the different dashboard pages. So I just have my main one, and that's the different product page. Okay, and let me end this. Just want to exit properly and get rid of the audio. Okay, so that was the demo. So I don't know why I stayed. So here is just in case I had some demo problems. So you can see here, this is what the game showed me yesterday. So very close, 356, 803, so 801. So again, within a couple seconds, difference of time. Um, so let me wrap things up. So wrap up, we talked about real-time medallion architecture for Formula One telemetry using Azure Data Explorer. So again, I use this as the backdrop. It's all about Santa and his sleigh, but he's joined Formula One to do some races over the holidays. Come January, he's got some time to kill before next Christmas. Um, and then, I showed how we can ingest, process, visualize high velocity data streams. So as data is flowing into the system, and then derive real time insights and performance analysis of that data. Allows the engineering team, the elves, to look at how Santa's performing on track as he comes in for a pit stop. And as you can see, there's some things that I can do to improve my demo. So look for that in a follow-up blog post. So let me show you, bring in, where is it? Should have had this tab open. So you go to github.com / Callon Campbell and go over to repositories. So I do have a repository right now for what you've seen called Medallion Architecture using Azure Data Explorer. I'll probably put up a specific one for the Festive Tech Calendar for changes that have changed from last month when I originally did this demo. But you can see here, you can see an older version of this presentation. You have all the assets, so images, the JSON data from cars and tracks. That's in here. So this is what I did. I loaded into the database. So again, when you go back to add data, you can just point to this JSON document and upload it. And then what else we have in here? We have source. So here's all the queries to set it up. Here's my dashboard. I'll update this because the dashboard has changed from last month. So again, look for a Festive Tech Calendar 2024 repository, but it will be largely similar to this. And then if you go back to the README, I'll just call out some references. So Forza Bridge is coming from Clemens, Vaster Clemens, original one. So mine's forked. As you can see here, I did make some changes. So if you want to look at what I've changed, I did do a PR to send back some improvements. If you don't have an Azure subscription, sign up for free. Azure Data Explorer, you don't even need an Azure subscription. You can just go get your free personal cluster. It takes like a minute. I give you some instructions for setting up. If you have any questions, just reach out to me and I'll show you when I get back to the slide deck my contact information. And then obviously you are watching this on YouTube, but you can go, there was a practice run I did last month that I uploaded for a meetup that I did. So that was the video that I demonstrated there. And where is, go back to my presentation for the rest of the Okay, so we did that. So references, Forza Motorsport, get it from Game Pass. A lot of what I showed you here does work for like the EA F1. You'd have to use a different, for the Forza Bridge won't work for EA F1, but there are other applications out there to do similar to that. And then this repository here from Blue Manos, this is where I got the Forza Motorsport car track ordinal information, so the tracks and the cars. So they do keep that updated as new tracks and cars are added to the game. So be sure to check that out. And then some documentation for Azure Data Explorer, and then implementing Medallion Lakehouse architecture in Fabric. So again, look out for my blog. Um, You can reach me here on LinkedIn, my GitHub, Flying Maverick, and my blog is actually theflyingmaverick.com. I should put that, update this slide, I forget. So thank you so much. It's been a pleasure to do this kind of presentation for the community. If you have any questions, reach out to me. Happy to help out. Have a great day and enjoy all the rest of the great content from this event. Thank you.